Okay, so hello students, we will be talking about objective questions from real numbers. So you must have seen your textbook from NCERT. So first chapter is real numbers, so we will be taking that. Let's look at the first question. The decimal expansion of the number 441 divided by 2 square into 5 cube into 7 has what kind of decimal expansion is it? Basically we want to know. So these are the following options, in which out of this one is correct. So let's look at the solution. So first of all, we will be solving the denominator, as in the powers in the denominators. So this will be 441 divided by 2 square is basically 2 multiplied by itself twice. So this will be taken as 4. Then 5 cube is 5 multiplied by itself thrice, that is 125 into 7. Now we will simplify this. Now we can cancel out 7 and 441. 7 and 441 will be cancelled with 63. Now you must have studied a statement that in a rational number, if we have a denominator which is of the power of 2 and 5 only, that means it has a terminal expansion. So in this case, the denominator has power of only 2 and 5, that means it has a terminating decimal expansion. So it is like 63 divided by 2 square into 5 cube. So it is evident from the denominator that it has the powers of 2 and 5 only. So the correct option is a terminating decimal expansion, that is option number A. Now let's move further for the second one. This is another type of question. First, so question says is n square minus 1 is divisible by 8 if n is what kind of number? So options are, it is an integer, or it is a natural number, or it is an odd integer, or it is an even number. So let's understand this. So in this case, what we will be doing is, we will be taking n square minus 1 as a. So a can be an odd number or an even number. Now you must have studied that for odd number, the expansion is 2n plus 1. So let's take n as 2n plus 1. This is the case when this a is an odd number. That this is your case 1. Now let us substitute the value of n as 2n plus 1 in this expression. Okay, since n and n is same, so we can take this n as k, so that we do not mix up the things. So what we can do is, we can substitute this in the given expression. So a will be equivalent to 2k plus 1 square minus 1. Now this is a form of a plus b whole square identity. So we will be using that identity to open this bracket. This will be equivalent to 4k square plus 4k plus 1 minus 1. Now this 1 and 1 will get cancelled and you will get 4k square plus 4k. Now this is by hit and trial method, we will be substituting different values to understand whether the given number is divisible by 8 or not. Let's see how. So we will take k as 0. So this will be you will get 0 plus 0 is equals to 0. So we get result as 0, which is divisible by 8. Now we will take k as 1. So what you will get? 4 plus 4, as in because 1 square is 1 itself. So we get 4 plus 4, which is 8. It is again divisible by 8. Now let's take k as minus 1. So anything raised to power 2, if you have a negative number, so it will become positive, because minus and minus, when you multiply them, you get a positive digit every time. So this is 4 minus 4, you get 0. Again 0 is divisible by 8. So we can say that in all the three cases, be it a positive integer, a negative integer or a 0, you are getting a number which is divisible by 8. So we can say that n square minus 1 is an odd integer. So this is your answer. Now let's move to the next question. The HCF of 95 and 152 is what? We need to calculate it. So you must have studied about Euclid's division algorithm or Euclid's division lemma. So they are both the same things. So that it is like, if you want to find out the HCF of A and B, so this is written as A plus A is equals to BQ plus R, where A is dividend, B is divisor, Q is quotient, and R is remainder. Now from normal division, we have understood that remainder cannot be greater than divisor and it should not be smaller than 0. Otherwise, if the remainder is 0, that means it is completely divisible by the divisor. So what we can say is that, so remainder is never less than 0 and cannot be greater than the divisor. So it's like this, as in R lies between 0 and B, where 0 is included. Now let us solve, and let's solve this and find out the HCF using Euclid's division lemma. Now here A is equivalent to 152, B is equivalent to 95. And one more thing I would like to add is, always dividend is greater than divisor. Now 152 is equals to 95 into 1. So we will subtract 95 out of 152, which is equivalent to 57. Now this divisor will become the dividend in next step. and this remainder will become quotient in next step. Now we will subtract 57 out of 95, which is equals to 38. Now in next step, this will become the dividend and this will become the divisor. Now we will subtract 38 out of 57, which is equivalent to 19. Now we will follow the same procedure, and this will become the dividend and this will become the divisor. So this will be 38 is equals to, now we know that if we multiply 19 with 2, you get 38 as the result. So 19 into 2, you will get remainder as 0. So from this step, when you get remainder as 0, this number, that is this divisor, will become your HCF. Now the answer is C part for this question. Now let us move further for the next question. Next question says that if two positive integers a and b are written as a is equals to x cube y square and b is equals to xy cube. So x and y are prime numbers, it is already given to us. Then HCF of AB is what? Options are xy, xy square, x cube y cube and x square y square. Now what is given? A is given to you as x cube y square, and we know that x and y are prime numbers. That means the prime factorization is already given to you. Let's understand this. B is given to you as xy cube. Now we know that HCF is the lowest power of the common numbers or the common digits in the prime factorization. So HCF will be given by x and y both are common, and lowest power in this case is 1 and lowest power for y is 2. So we have the answer as xy square. That is your option number B. I hope you have understood this clearly. Let's move to the next question. Next question says that the decimal expansion of the rational number 33 divided by 2 square into 5 will terminate after which decimal place? So options given to you are 1 decimal place, 2 decimal places, 3 decimal places and more than 3 decimal places. Let's see how to solve this. Okay, one thing I would like to remind you is that we have done this in first question also. How do we identify that this rational number has a terminating decimal expansion? Because the denominator has the powers of 2 and 5 only. So we can say that this has a terminating decimal expansion. Now let's see what will be the terminating decimal expansion for this. So it is 33 2 square into 5. Now 2 square can be written as 4. So 33 divided by 4 into 5, which is 33 divided by 20. Now this 20 can be written as 33 upon 2 into 10. So 33 divided by 2 will be equal to 6. So okay, there is a mistake. So what we can do is it's 1.65 because we have the 10 in the denominator as well. Now what we have observed is it ends after 2 decimal places. So option is B. This is the correct answer. Now let's move further and let's look at another question. Question is, if the sum of LCM and HCF of two numbers is 1260 and their LCM is 900 more than their HCF, then the product of two numbers is dash. Now this is a kind of linear equation. Let's understand how. We will form linear equations in this. Let's see how. What is given? Sum of LCM and HCF. That means LCM plus HCF is equals to 1260. Now second equation is their LCM is 900 more than their HCF. So HCF plus 900 is equals to LCM. Now we have these two equations and we need to find out the LCM and HCF. Let's see how. So this will be your first equation and this will be your second equation. Now we will substitute equation number 2 in equation number 1. In place of LCM we will write HCF plus 900. Let's see how. So this is HCF plus 900 plus HCF is equals to 1260. Now this is kind of a variable for us. Now what do we have is twice of HCF plus 900 is equals to 1260. Now we will take 900 to the other side. Now let's subtract this. So what do we get? You will get 360 as the result upon subtraction. Now HCF will be 360 divided by this 2. So we get HCF as 180. Now since we have calculated HCF, let us substitute this value in equation number 2 to calculate LCM. So this is 180 plus 900 is equals to LCM. So LCM will be equal to 1080. Now we have calculated LCM and HCF, and also we know that product of numbers is equals to product of LCM and HCF, and we need to calculate the product of numbers. So product of numbers will be that is LCM we have already calculated as 1080 and HCF we have calculated as 180. So now multiply this and what you will get? You will get the result B, that is 194400. This is your answer. So we get result as B. Now let's move further for the next question, that is the 7th one. So 7th question says that if A is equals to 2 cube into 3 and B is equals to 2 into 3 into 5, as in the prime factorization for A and B is already given to you. C is given to you as 3 raised to n into 5, and LCM is given to you as 2 cube into 3 square into 5, then you need to find out the value of n. Let's see how to do this. We know that LCM is the highest powers of all the factors. So we define LCM as And given LCM is 2 cube into 3 square into 5. Now from all the given 3 numbers, we know that highest power of 2 is 3. Highest power of 3 is, we don't know. See, it's n and 3, power of 3 is 1 and again power of 3 is 1. So what do we calculate is n is equals to 2. That is the highest power of 3. So answer is B part. This is how we solve this question. Let's move to the next question. Now the next question says that